Today, we want to continue our game of solving triangles with solving oblique triangles. This is very similar to what we did at the beginning of the semester, where of the 6 parts of a triangle, I give you 3 of them and ask you to find the other 3. When we originally started playing this game, we were solving right triangles, and so one of the pieces of given information was that one of the angles was a 90-degree angle. Then I gave you 2 other things. Now we're just changing it up a little bit. I'm going to still give you 3 pieces of information about the triangle, but one of them is not going to be a 90-degree angle. We have to update our tool set. So check the previous notes and videos for the updated tool set, but here they are in summary. The sum of the angles is still 180 degrees. That tool carries over from what we had before. That's always true. In any triangle, the sum of the angles is 180 degrees. This is the first thing that we should go for as soon as we have 2 angles. As soon as you know 2 angles, you just need to subtract to find the 3rd angle, and you're 1 step closer to solving the rest of the parts. We don't get to use the Pythagorean theorem anymore because that requires a hypotenuse. And if we don't have a right angle, we don't have a hypotenuse. So we don't get to use the Pythagorean theorem. So we had the generalization of the Pythagorean theorem, and that was the law of cosines. I know I wrote it 3rd, I talked about it 2nd. It's 3rd in the priority because it's messy. But notice that if one of these angles is a 90-degree angle, then the law of cosines becomes the Pythagorean theorem because the cosine of 90 degrees is 0. And so this minus 2ab cosine of 90 drops out to c squared equals a squared plus b squared. So the law of cosines is just a better version of the Pythagorean theorem. Plus, we don't have to have c be the hypotenuse. That does mean we have 3 versions of the law of cosine: the c and gamma, the b and beta, the a and alpha one. The law of cosines is the rule that we use. It's the tool that we pull out when we do not have a set of opposite parts. By opposite parts, I mean a and alpha, b and beta, c and gamma. So if we don't have a set of opposite parts, then we have to use the law of cosines. As soon as we have a set of opposite parts, we could start using the law of sines, which is preferable because it's a lot smaller. I have all 3 versions of the law of sines in one little line here. Your hierarchy is sum of the angles first, law of sines second, law of cosines third. There is something to watch out for in the law of sines. If you're using the law of sines to find the 4th piece of information, that is the first tactic is to use the law of sines, then you are in what is called the, if you're using the law of sines to find an angle first, then that is the ambiguous case. So be careful. If your first move is to use the law of sines to find an angle, that's the ambiguous case. The ambiguous case of the law of sines is when your first move, you have 3 pieces of information, and the first thing you're going to find is an angle, and you're using the law of sines. That is the ambiguous case of the law of sines. The trouble here is that there could be 0, 1, 2, or 1 triangles. Could be 0, 1, 2, or 1 triangle. I know I said one twice. That first one is a right triangle, which is really hard to land on, so don't worry about that too much. But it could be that you're actually solving two triangles. The given information fits two different triangles. So we're going to have to learn how to deal with that. Oh. This is only the 0, 1, 2, or 1 triangles. The ambiguous case of the law of sines is only when your very first thing to do is to find an angle with the law of sines. That's the ambiguous case. Every other time, you'll be fine. You don't have to worry about this 2 triangles line. All right. Today, we're just going to do some more examples. Last time we did an example where we had 2 sides and the included angle. That means we had to use the law of cosines for our opener. So 2 sides and the included angle would be something like side A, side B, and angle gamma. Or side B and side C and angle alpha. That's what I mean by the included side. The other time that you'll use the law of cosines as your opener is if you have 3 sides. So let's do an example. Let's suppose that we're given side A is 12.3, side B is 17.8, and side C is 24.5. So we're given all 3 sides. We're given all 3 sides, which means we do not have a set of opposite parts. So that means we have to use the law of cosines. So we do not have a set of opposite parts. So we're going to have to use the law of cosines to find our first angle. Let's give units to all these. The good news is that in this case, where we have all 3 sides for our opener, we can choose to find any one of the angles that we want to find. We can just pick whatever angle we want to find first. We can find angle alpha, angle beta, or angle gamma. My recommendation is that you find the biggest angle first. We can choose to find any of the 3 angles first. My recommendation is go for the biggest angle first. So you can choose to find any angle first, but I recommend that you just find the biggest one first, but just to avoid confusion. I recommend finding the largest angle first. With the 3 sides already set, it's not like we can have multiple triangles. But we want to avoid confusion, and one way to avoid confusion is to just find the biggest angle first, in case we forget that we have all the angles set. So with that in mind, side A is 12.3, side B is 17.8, and side C is 24.5. That means gamma is going to be the largest angle. The largest angle will be opposite the largest side. Since side C is the largest side, angle gamma will be the largest angle. So that's the one I want to find first. Since we're using the law of cosines to find an angle, it's useful to learn the law of cosines, the side style, and law of cosines for angles. So this is the version of the law of cosines I want to use because it involves the angle gamma, the one that I want to find because it's the largest angle, because it's opposite the largest side. Before we drop any numbers in here, let's write down the expression for gamma. So let's solve for gamma first. So here is the term with gamma in it. I got minus 2ab cosine of gamma. So I'm going to start off by subtracting a squared and b squared from both sides. So I'm going to rewrite this as c squared minus a squared minus b squared is equal to minus 2ab cosine gamma. Now I'm going to solve for cosine gamma. I'm going to divide by the negative 2ab. So I'm going to have c squared minus a squared minus b squared divided by minus 2ab. Is equal to cosine gamma. Now I'm going to look at this fraction and say, ew, there's a negative factor in the denominator. Ugh. Negative 2ab. That looks terrible. I don't know if you've acquired this particular prejudice, but I'm trying to imprint that on you. That looks terrible. I want you to look at this over minus 2ab and go, ugh, that looks terrible. Just imagine yourself looking at that and feeling disgust. Ew. Dividing by minus 2ab, especially when there's negatives in the numerator. Let's change all the signs. I'm going to multiply by 1. I'm going to change all the signs. And I'm going to rewrite this. This looks terrible. So I'm going to write cosine of gamma is equal to a squared plus b squared. And make those two positive and subtract the c squared. And then I can just divide by 2ab. And now you're going to look at this and say, yeah, that looks much better. Don't know why. It's probably completely subjective. It's kind of like wheels on cars. I don't know if you like cars at all. But like whatever size the manufacturer puts on their car, it looks better if you just go up 1 inch. Car ships with 17-inch wheels. When you put 18-inch wheels on it, all of a sudden the car looks better. No matter how big the wheels were when they came from the manufacturer. That's why wheels are so damn big now. You got this big SUV, it ships with 22-inch wheels from the factory. And you're like, oh, that looks good. I'm going to put some 23s on it. Then you put 23s on it, realize it's an SUV. You've now got 1 inch of rubber on a 6,000-pound vehicle, and it rides like shit. But man, it looks good. I thought, wow, that looks much better. You know what I mean? I don't know if you've modified your wheels. So this negative divided by negative 2AB, that looks terrible, especially when I can just distribute that negative. Make a positive 2AB, negative C squared, positive A squared, positive B squared. Just change all the signs that you see. Now, to find out what gamma is, we just have to cosine inverse all of this business. So that gets us to gamma equals cosine inverse of A squared plus B squared minus C squared, close parentheses, divided by open parentheses 2AB, close parentheses, close the cosine. And now we have a new version of the law of cosines that's specifically designed for angles. I wrote this in single line syntax because we want to put this into our calculating machines, and we want to put it into our calculating machines and hit enter one time. You don't want to have a bunch of subtotals running around where you have to round some stuff off and then type a whole number in again. You want to plug it in once and then hit enter once. And of course, you also want to make sure that you don't give yourself enough space. So let's see, A is 12.3 centimeters. B is 17.8 centimeters. And C is 24.5 centimeters. And we've got a new version of the law of sines that says gamma, law of cosines, is cosine inverse of A squared plus B squared minus C squared, close parentheses, divided by open parentheses, 2AB, close parentheses again. Remember, it's a gamma and the C that go together. It's going to be A squared plus B squared minus C squared divided by 2AB. Now we can just drop all this into our, or drop A, B, and C into this expression. It's going to be cosine inverse of parentheses 12.3 squared plus 17.8 squared minus 24.5 squared, close parentheses, divided by open parentheses, 2 times 12.3 times 17.8. Close parentheses again, and then hit enter. Second cosine inverse, 12.3 squared, parentheses. Got to have those double parentheses because I need parentheses around the numerator and parentheses around the denominator because there's operations in there. 12.3 squared plus 17.8 squared minus 24.5 squared. Close the numerator, divide by open the denominator. 2 times 12.3 times 17.8. Close the denominator, close the cosine inverse, and hit enter. 107.6 degrees. We call it 108 degrees. Any questions? We now have options, which is what makes for these problems difficult if I'm asking you to solve the entire triangle. So good news, we get to choose how to proceed from here. We can continue using the law of cosines, it seems pretty simple. Or we can switch it up and do the law of sine. Bad news, we can choose how we want to proceed, and that means we have to choose. Usually it's easier to use the law of sines, but it's also not that bad to just permute this into a beta version. So we can choose to use the law of cosines again, or we can switch to the law of sines since we have a set of opposite information, in particular, side C and angle gamma. If we use angle gamma, we shouldn't round it off all the way to 108. We should just keep it as it is, all those decimal places. We shouldn't type all those decimal places, but we should keep that on our calculator. If we want to switch to the law of sines, we would say that the sine of 108 divided by side C, so this is gamma over here, 24.5, is equal to the sine of beta divided by B. Here's us choosing to switch to the law of sines because we have a set of opposite parts. I've been saying parts, not information. Now we just have to solve for sine for beta. I can multiply both sides by 17.8 and do the sine inverse. So beta is sine inverse of 17.8 times the sine of 108 divided by 24.5. But instead of typing 108, I'm going to say sine inverse of 17.8 times the sine of that 107.56133303, close parentheses, then divide by the 24.5. Then close the sine inverse and hit enter. And there's our beta. At this point, we have one more piece to find. We can use the law of cosines to find it if we want. We can use the law of sines to find it if we want. Or since we know two angles, we can just subtract to find the third angle. So good news, we have choices. Bad news, we have choices. So to find that third angle, I'll just say alpha is 180 minus the 108 minus the 43.8. Here, since we're just subtracting, it's less critical to make sure you use rounded information just 180 minus 108 minus 43.8, 28.2. Make our third angle. You're under the most restriction when you have the least information. Those first three pieces of information are going to dictate how you proceed. After that, you will have choices. So just be aware of the choices that you can make. Let's do alternate reality. Let's suppose that we just have gamma is 108, and we can use the law of cosines to find beta and alpha. This is good practice for learning our law of cosines. So beta can be the cosine inverse, and I'm just going to rewrite this expression, but I'm going to trade my gamma for a beta, so I'm going to have to switch around my b's and my c's. So it's going to be a squared plus c squared minus b squared, close parentheses, divided by open parentheses, 2ac, close parentheses, close the cosine. I'm just going to have to translate it. If I replace the gamma with a beta, I just replace c with b. Still need double parentheses after my cosine, and it's going to be a is 12.3 squared plus c this time 24.5 squared minus b 17.8 squared. Close the numerator, divide by, open the denominator, 2 times 12.3 times 17.8. Sorry, 24.5. Close the denominator, close the cosine inverse. Start a typing. Cosine inverse, open for the numerator, 12.3 squared plus 24.5 squared minus 17.8 squared, because we're looking for beta this time. Close the numerator, divide by, open the denominator, 2 times 12.3 times 24.5, close the denominator, close the cosine inverse. Finally, we can hit enter, and we get the same beta, 43.8 degrees. Once we have the two angles, we just subtract to find the third angle. Or we could be like, oh, dude, law of cosines is so awesome. Let's do that again. Let's practice rewriting it. So alpha is cosine inverse of, open the numerator. Now alpha is going to go in the place where the b, or a is going to go in the place where the b is. So it'll be b squared plus c squared minus a squared. Close the numerator and divide by 2. Open the denominator. Slow is smooth and smooth is fast. Close the numerator, divide, open the denominator, 2 times BC. Close the denominator, close the cosine inverse. Now we just have to plug in the 3 sides. So B is 17.8 squared plus C 24.5 squared minus A squared 12.3 squared. Close the numerator, divide by, open the denominator, 2 times 17.8 times 24.5. Close the denominator, close the cosine. Get to typing. Did I just type something? I think I know what it is. I think my problem is my original 108 is not very good. Cosine inverse of, let's redo that one. 12.3 squared plus 17 point. Now I remember. I rounded that kind of a lot. And I rounded it off by 0.4, and that accounts for the difference in the 0.4. That's what it was. That 108 was rounded by 0.4, because it should be 107.6. And I just put that at 108. That 0.4 is the difference between the 28.2 that I put for alpha originally and the 28.6 that I have for alpha down here. So rounding error. Get you every time. Brings up an important point, though. Although we had to do more typing down here when we just used the law of cosines a bunch of times, notice that every number that we punched into the calculator was one of our given numbers. Nothing was rounded when we just used the law of cosines. Over in the previous problem, didn't use the 108, I used the unrounded 107.56. And so that 43.8 is accurate, but the 108 was not. And then I used that rounded information down here and it caused error. So my mistake was subtracting 108 from the 180, because now that I've got this 107.56, if I use that in my alpha calculate, my orange alpha calculation, if I type 180 minus this number minus the 43.8, that gives me the 28.6 that we got when we stopped using rounded information. So use rounded information as little as possible, or just carry all your decimals. Any questions? In that regard, The TI-84 is a great calculator for this because it remembers the last thing that you type. You don't have to mess with the memory function. So it is superior to your phone calculator. But as long as you're using your phone calculator correctly, everything will work out fine. Your phone calculator has a memory. At most, you're going to have to store one number to see to find the next number. Any questions? All right, let's take a quick break, come back, and then we'll look at a different example.